Let's learn angular speed and its relationship with usual linear speed. To start, let's say the object is moving on circumference of a circle and it's detected here at time t1. And it travels for delta theta, this is the angular displacement, and it's detected here at time t2. The total angle traveled around the circle in unit time is angular speed. It could be defined as delta theta over delta t, radians per second, number of radians in each second. So omega bar is actually number of radians in each second. Let's say omega bar is 10 radians per second, means that if you wait for 1 second, it will travel for delta theta equals 10 radians. Uh, but what the bar sign is on top? Bar sign actually is indicating the average. And in general, you know that we don't know the behavior of the object between T1 and T2. It's not going to be necessarily a uniform circular motion. So if you use bar sign, but if it is a uniform circular motion, I mean, it's like a car moving at constant speed on this circle, it's going to be the uniform. So in uniform circular motion, average and instantaneous angular speeds are equal. The reason is that the object is actually traveling for similar delta theta in similar time intervals. So we can get rid of bar sign on top. And to simplify, we can say the object starts from here, from the origin, and so delta theta is theta. And here delta t is t if we start our stopwatch from 0. So we rearrange the equation and write it as theta equals omega t. Theta here is the angular displacement travel for the time interval of t, and omega is angular speed. Uh, Rather than number of radians in each second, which is another identification for omega, we can also call it angular frequency. I will tell you why. So angular speed is sometimes called angular frequency. As a reminder, you remember in uniform linear motion, when the object is moving at constant velocity, x is equal to vt. Here I have uniform circular motion and theta is omega t. X is displacement, now theta is angular displacement, and v is speed, omega is angular speed. It's very interesting similarity. Not to mix them up, from now on, let's say v is linear speed instead of a speed. Okay, here I have a question. Is omega really vector? Is it really angular velocity or no, just angular speed? The answer is omega is a vector, yeah. Angular velocity is a vector passing through the center of the circle around which the object is moving and perpendicular to the plane of rotation. The direction follows the clockwise corkscrew rule. You should put your right hand fingers to the direction of rotation and your thumb will be perpendicular to the plane of rotation and shows the direction of omega. But for the time being, we usually ignore the vector properties of omega and let's say it's angular speed. Let's link angular speed, period, and frequency. You remember omega was delta theta divided by delta t. Let's say object goes round the circle. So the total angle traveled is 2 pi. Accordingly, the time you need for this travel is a period, because period is a time to have one full cycle. So here omega seems to be 2 pi divided by t. And as frequency is 1 over t, I can write it as 2 pi times frequency. This is a very important relationship. Now I'm going to link angular and linear speeds. Let's say that an object is moving on the circle at a speed of v, okay? V is going to be the total distance traveled divided by time. Let's say the object goes round the circle, so the total distance traveled is the circumference of the circle and the corresponding time is a period. If I solve it for t, t is going to be the circumference of the circle divided by v. On the other hand, omega was 2 pi divided by t. And if I rearrange the equation and solve it for t, I will have t equals 2 pi divided by omega. Let's put them equal. 2 pi r divided by v is 2 pi divided by omega. If I drop the 2 pi's, I will have v is equal to r omega. linear speed, angular speed. They are connected via r. I have something very important now for you. For a solid object, let's say there is a solid object, or in general rigid object or rigid body like a wheel of the car, and it's rotating, okay? If you take every point on this wheel, here, 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 normally they will have the same frequency of rotation. If the point A goes round the circle and travels for one complete cycle, the point B also will do that, the point C also will do that. It's very important. They have the same frequency. Likewise, they will have the same angular frequency. So omega will be the same for all the points of this solid object. But speed is different. Actually, if you take the uppermost point, I mean the point which is in the highest distance to the center, basically the v is the largest because v is equal to r omega. Omega is the same, but r is different. If you take a point here, the distance to the center is different, the radius of rotation is different, so velocity or speed cannot be the same. So velocity for the points further away from the center will be larger and larger, but omega same. Let's answer this question. Helicopter blades of radius 5 meter are rotating at a frequency of 100 hertz. Find the tip speed of blades. Tip speed is the speed of here, the point to the which is at the maximum distance to the center. Tip speed. How to find it? We need v, tip speed, and so I will use v equals r omega. R is the radius. The radius of the blade is given to be 5, and omega is going to be 2 pi times frequency. Frequency of rotation is 100 hertz. Let's plug in the values, 2 pi times frequency. And here I will have 62,800 meter per second. It's a very high speed, as you see. Another question. A car is traveling at a constant speed of 36 kilometers per hour. The wheels have a radius of 40 centimeters. Find the frequency of rotation of wheels. I'm looking for frequency, and the V is given, but it's not in SI units. Let's convert it. V is gonna be 36 divided by 3.6 to convert it to SI units. It's gonna be 10 meter per second. Now I use the same relation. V is equal to R omega. V is 10 meter per second, as I told you. R is the radius in SI in meter. It will be 0.4. And omega is gonna be 2 pi times F. So omega is 25, on the other hand 2 pi times F. And F is gonna be 25 divided by 2 pi. Here frequency is almost 4 hertz. So the wheel will rotate for 4 complete cycles in every second. The motion of Earth around the Sun can be modeled as uniform circular motion around an orbit of radius 1.5 10 to 11 meter. Calculate for the orbital motion of Earth the angular speed and linear speed. Okay, angular speed is omega. I can use the basic relation 2 pi divided by t. T is the period of orbital motion. You know, orbital motion of the Earth around the Sun takes 1 year. And 1 year is going to be 365 days. And each day is going to be 24 hours. And each hour is going to be 3,600 seconds. Why I'm doing that? Because downstairs must be in SI units. So let's do it. 365 days, 24 hours, and 3,600 seconds. Omega is going to be 1.99 10 to negative 7 radians per second. This is angular speed, but linear speed is v. We should use r omega, and r is given. So let's plug in the values. This is r, and this is the omega. And so the speed, linear speed is 9.98 10 to 4 meter per second. A large clock on a building has a minute hand that's 4.2 meter long. Calculate the angular speed of the minute hand. Angular speed is omega. Omega is delta theta over delta t or 2 pi divided by t. I prefer this one. T is the period. Think about the minute hand. It takes 1 hour for the minute hand to go round the clock, which is 3600 seconds. I always use SI units here. So let's do it and find this value for omega as a standard omega for every minute hand. Regardless of the size of the clock, it's always the same because period of minute hand is always 1 hour. Part B. The angular displacement in radians in the time intervals of 12 noon to 12:20 and 12 noon to 14:30. Here I have a time interval, angular displacement is delta theta. And here I have a time interval of 20 minutes, okay? Remember, the period for minute hand is 1 hour, so it's 60 minutes. 20 minutes seems to be a third of 60 minutes, so it's a third of period. In one period, the minute hand goes for 2 pi. So here is going to be a third of 2 pi. So the answer for BI is going to be a third of 2 pi. Look at this time interval. This time interval is 2 hours and 30 minutes. Okay? 2 hours means 2 of 2 pi because in each hour is one period. It goes for 2 pi. So it's 2 of 2 pi. 30 minutes is a half of a period, so it's a half of 2 pi. In total, it's gonna be 2.5 times 2 pi. This is the angular displacement for the second time interval. Part C, the linear speed of the tip of the minute hand. Tip speed is different from the other points. You remember I told you when a solid object is rotating, the speeds of different points are different because v is equal to r omega. Omega is the same for all points, but r is different. Tip speed means you should use the maximum distance to the center, the full length of this minute hand. So let's take it to be 4.2 meters. And this is the omega. And I have converted the answer to millimeter per second, 7.3 millimeters per second. Let's summarize our discussion and make a map. Here I have a sector of the circle. I have some angular quantities here, and here I have linear quantities. Okay, what do I mean by that? Theta, you know, it's the angle. So it's a kind of angular quantity related highly to this circle. And if I divide it by time, I will get omega because omega is theta over t. And if I go back, I should multiply it by t. So it's gonna be theta is equal to omega t. So for horizontal movement, here to the right, you divide it by time, and to the left, you multiply by time. To go to the linear quantities on the circumference, I use the elevator of radius. This elevator takes me to the linear quantities. S is the arc length, the distance traveled, the linear distance, okay? And here, if I multiply omega by r, I will get v. And you know that S is r theta and v is r omega. So to go from angular quantities to linear quantities, you should use the elevator of r. Likewise, if you go from right to left, you should divide it by time. And you know that v is s divided by t. And if you go back, you should multiply by t because s is gonna be vt. It's a very simple map to summarize all we have learned so far. Thank you very much for watching this video and for being with me. Take care. See you.